Good morning, everybody, or afternoon, depending on when you're looking at this. I hope you've had a lovely weekend. You've enjoyed some sunshine, got a bit of a rest. So I'm going to show you. I'm going to give a little go at kind of talking over a PowerPoint and writing on it. Now, I'm not very good at writing on the screen with the stylus, so you'll have to forgive my terrible handwriting. I've had a few attempts at this video already, so I'm going to just go for this one now because I'm just wasting my Sunday away at the moment. But we'll give it a go. So first of all, I'm just going to highlight to you which bit of the knowledge organizer I'm going to be talking about. So I'll use a nice purple colour, why not? So we're going to be looking at this bit here. So we've got energy resource, two types of energy resource. We've got the non-renewable and the renewable energy resources. And then here is an example at the bottom of a type of non-renewable energy resource. And I'm going to go through with you these words anyway in a second, but just to highlight to you, that is the part of the knowledge organizer that you're going to use. Right, so what is an energy resource? It's something with stored energy that can be released in a useful way. Now, very often when we're talking about energy resources, we're actually talking about making, I told you my writing was bad, electricity. Okay, now you're very familiar, I'm sure, with what electricity is. By the way, that's a C. It looks like an E, doesn't it? There you go. Electricity. And that's okay. Oh dear. There we go. That's the best I can do. So, yeah, making electricity. So you use it all the time, I'm sure, charging your phone, watching television, switching on a light, heating your home. You're very familiar with what electricity is useful for, what we use it for. You may not know how it's made, and that's what I'm going to talk about in a minute. It doesn't have to be making electricity, though. It could be something like burning petrol so that you can use it in a car to transport yourself. So you would use the petrol or the diesel, burn that, and then cause the mechanics of the car to move you. So those are the two main things that when we're talking about energy resources, we're really kind of talking about. Very, very often we're talking about making electricity. And on that note, let's try and answer this question here then. How is electricity actually made? So I'm going to use someone else's resource down here because it is much more straightforward to understand than me just trying to talk about it. So how is electricity actually made? Well, it's fairly straightforward actually. Now, how the actual current is made, you don't really need to understand, but it's made here over here in a generator. And all a generator is a massive, massive coil, like really, really big coil of wire, usually made of copper. And all you need to do to induce what we call an electrical current, the current is the electricity flowing through the wire. All you need to do is you need to spin a very, very big and powerful magnet within your coil of wire. So when you generate electricity, you have to have an element of spinning. Now, usually it uses some kind of turbine. So you can see here on my diagram, the turbine is moving around. Inside of here, what that's doing is spinning a massive magnet inside of a coil of wire, and through some physics laws that you will learn about in year 9, that generates an electrical current in the wire. Okay. Now, the method of turning a turbine differs depending on what type of energy resource you've got. Now, with the power stations, which are usually fossil fuel based, all you need to do is heat up some water. Now, as you know, when water is heated past its boiling point, we get a state change, don't we? We change from liquid water to gas, and you can see that steam is moving up here. It's forced through these tubes. It's funneled through the pipes. Couldn't think of the word then. And then the turbine is turned. Okay, what that does is causes the generator to work, the electricity to be made. And once it's finished, it can be used again. So it condenses down in the condenser, turns back to liquid, and then is reused again in the boiler. The water just cycles around gas, liquid, gas, liquid, and in doing so, it turns the turbine as it moves across it. Now, the only difference really between the power stations is that the method of heating up the water. So you can see this is oil, this is a fossil fuel, and I could change it if I wanted to gas. So we burn the gas instead. It has the same effect on the water. Or I could use some... Okay, that's my door, really unhelpfully. Just a second, I'm going to see if I can pause this video. Right, sorry about that, guys. That was my neighbours bringing me some eggs, which is very nice of them, but kind of interrupted what I was saying. So I've a little bit forgotten where I was. I think I was talking about, wasn't I, that you could just change the method of heating up the water. So if I look at coal, see it's the same thing. All of this bit here is exactly the same. But it's the method of heating up which changes. And finally, I'll show it to you since it's here. We've got nuclear as well, also the same. Now, you might have heard of nuclear power. I'll talk a little bit about it later. But essentially, you use something called a nuclear reactor, which splits atoms, usually of something called uranium-235, which is an element, usually uranium, which heats up the water, generates heat when you split an atom. We'll talk a little bit more about that one shortly. Okay, so hopefully, oops, I've still got all of this information. There we go. Hopefully that explains how electricity is made. So the concept really is, so long as you can turn a turbine, you can make electricity, so long as you've got a magnet and a large coil of wire. So let's talk about the non-renewable energy resources first. Now, I'm sorry, this might make a bit of a noise. I'm just going to change it so that I can... Ooh, gone upside down, there we go. So that I can type and write without making too much noise, hopefully. So we've got the non-renewable resources here, what we call the fossil fuels. And the key, I guess, really the obvious thing, word there is fossil. They are fossilized remains of living things. Okay, so it depends on which one you're looking at as to which type of fossil it is. Now, fossils take an extremely long time to make. So we've got coal here at the top. You can see coal is actually made of dead trees. So trees that have died, fallen into swamps, and they haven't just completely broken down and been reused, that we talked about when we were talking about things decaying before. They actually got stuck in the swamp, and then over time layers have built up over the top of them of other things, soil and dirt, and you can see the layer of dead plants has moved down here, and then over a long time, and we're talking like hundreds of millions of years, this has all turned to rock. Okay, you've got a big layer of rock, and at the bottom you've got your now fossilized trees. Okay, now where did the energy come from originally? Well, we've done this already. If you think about it, what do trees do? They go through the process of photosynthesis. Okay, and that makes glucose, and glucose is stored then in the trees, and when they die, that is still there, and it's still there when it's been fossilized. It's essentially fossilized glucose in the coal. Oil and gas are very similar in terms of how they are made, but it is not made of dead trees from falling into swamps. It's actually made of dead sea creatures and sea plants. So here's what oil and gas are both made of here. And you can see same process, layers of our dead plants and animals there. And then eventually, after the rock has built up over the top, a few 100 million years later, we've got oil and gas. So that's why you find oil and gas underneath the sea, because they are both made of dead sea creatures. So some disadvantages of fossil fuels first, I think, that you will have heard of. Now, one of the major things is that when you burn oil and gas, and whatever the one I just didn't say was, coal, you release this gas here, CO2 or carbon dioxide. Now that is not helpful because it contributes to something called the greenhouse effect, and then in turn global warming. Okay, so lots and lots of people want to try and reduce their greenhouse gas emissions, and by using oil and coal and gas fired power stations, you're not going to do that. The other gas that it releases is sulfur dioxide. This isn't a greenhouse gas, but what it does is it leads to something called acid rain, dissolves in the rain clouds and makes the rain a very weak acid, but enough to cause some problems in rivers with animals like fish, but also it can have some adverse effects on buildings, so not helpful. Good things about it though, I'm going to change colour, see if I can put some good things on. Generally, it's very cheap, easy to get hold of, easy to transport, easy to make electricity with. Okay. I think that is all I've got to say about the non-renewable fossil fuels at the moment. This one's an interesting one, biomass. Now, if you remember, we've done biomass already, and I'll remind you that bio means life or living, and mass is how much stuff or how much matter. So it's the living matter. If you think about what living matter is, it's kind of carbohydrates, fats, and proteins in living things. Now, they store energy, and you can, in exactly the same way as fossil fuels do. So you can think of the main one you probably think of is burning wood. Okay, now this is a bit of a confusing one because sometimes this is referred to as non-renewable. So if you cut down all of the trees and burnt them all, then you have no trees left and it's non-renewable. But sometimes you can class this as renewable, because what you can do is you can, for every tree that you chop down, you can plant another one. So I'm just going to explain what this thing down here means, carbon neutral. So I'm going to draw a little tree here, probably very badly. Here's my tree. Now, trees take carbon dioxide out of the atmosphere, out of the air. Okay, here's the atmosphere. Okay, so they take it out during the process of photosynthesis, but they also, if you then burn a tree, so let's get rid of the tree, and you burn it, it's a fire, it's supposed to be a fire, you release carbon dioxide back to the atmosphere. Now, if you can balance that out, if you can plant trees to make up for the ones that are being burnt, then you take out the same amount of carbon dioxide as you put back in, then we call that carbon neutral. There is no overall increase in carbon dioxide in the atmosphere, and therefore there's no overall increase in the greenhouse effect. But if you get that balance wrong, if you then you can end up with this. Now, I know you've learned about this in geography. This is what's called deforestation, where the removal of trees is faster than the replanting of trees. Okay, so it's not without its downsides, but it's certainly probably better for the environment than using fossil fuels. Okay, and the last non-renewable one is the nuclear power station. Now, you may have heard of nuclear power as being quite a negative thing because there has been a few big disasters. So this picture here is Chernobyl, which was a big power plant disaster, a nuclear power plant. And in fact, it was on the 26th of April, and I'm recording this on Sunday. It is actually the 26th of April. So it was on 34 years ago today, so in 1986, that the Chernobyl disaster happened. And if you're watching this on Monday, which you will be, then it was 34 years yesterday that this happened. And generally, nuclear power plants are very safe. However, if something goes wrong, it's usually very wrong. Okay. Now, as I said to you before, the way that nuclear energy is released from the source is by splitting an atom. Okay, and it's an atom usually of something called uranium-235. And when you do that, you release a lot of energy. So you can contain this reaction, then, and that's fine. But sometimes the reaction gets out of control, which is what leads to the nuclear disaster. Not only that, they are incredibly expensive. So that's why I've put these pound signs here. Very expensive to set up and decommission. So that means take down again once it's finished its lifespan, because you can't just keep using a power station forever. Things need to be replaced, and they get decommissioned, they get taken down and kind of built elsewhere. So that's very expensive. And one major downside is this stuff here. This is nuclear waste. Once you've split your atom, unfortunately, what you're left with is waste products which are very radioactive. What that means is they're throwing out something called radiation, which has various forms. It's not very good for you and can cause problems. So the nuclear waste has to be stored very carefully in special containers, like so. Which obviously has its own problems, and this stuff remains radioactive for many years. Okay, possibly thousands of years. So it's not just a kind of, oh, you've got to keep it for a couple of years and then you can get rid of it into landfill. It is in these cases for a very long time. So some good things though, we don't get any greenhouse gases. So it doesn't contribute in any way to global warming or acid rain, which is really helpful. And you get loads of energy from not very much uranium. So it's really efficient in that sense. Okay. Right, let's have a quick look at the renewable energy resources. Now, I'm not going to labour them too much because you're going to see them on both the Seneca task and on the Key Stage 3 bite-size video and pages that I've asked you to look at. So I'm not going to go through all the ins and outs of how they work, but I will give you a couple of advantages. Now, for all of them, there is no fuel cost because none of them have any fuel involved. So, sorry, I should have said what a renewable one is, really, shouldn't I? So a renewable energy resource is something that will not run out, which in itself is also an advantage, isn't it? If it will not run out, then that's an advantage. It's going to keep being there forever. So things like the wind, anything to do with water, waves or tides, or something called hydroelectric, and solar, the sun. Hopefully that's not going to run out anytime soon. So we've got with constant supply of these. So they've got no fuel costs, so you're not burning anything. And that also means that we're not going to get no polluting gases. We're not going to get any sulfur dioxide for acid rain, and we're not going to get any carbon dioxide for the global warming. So it's really good for that. They won't run out as well, so we could put that as an advantage as well if we wanted to. Now, disadvantages, each one has its own kind of set of disadvantages, which you can see very clearly on the Key Stage 3 bite-size website I've asked you to look at. But one of the main ones is really to do with location and how reliable these things are. So, for example, if you put a wind turbine where there is not very much wind, or if the wind is a bit sketchy, some days it's windy, some days it's not, then that is going to directly impact how much electricity you can get from your particular wind turbine. Okay, or geothermal, which is a really great source of heating up water, but you have to have it in somewhere that's volcanic, so obviously that can't be anywhere that you want to put it. And same with the sun. If it's really cloudy, can you get enough solar energy to generate enough electricity, etc.? So I think I was going to go through each one, but I think I'll very quickly talk about them. But I think you probably can go and find out about them on your own on the Key Stage 3 Bitesider website, rather than me basically say the same thing and then you read the same thing again. But essentially, remember what I said, if you can turn a turbine, you can generate electricity. What is a wind turbine? It's a big turbine, using the same word, which has a generator in it. Okay, exactly the same. You're not using steam to turn it, you're using wind. Obviously, that's free. They are massive though, so some people don't like say that they kind of pollute the environment in terms of what they look like. They can, as they're spinning around, they have they can kill quite a lot of birds. That's the disadvantage of them. And as I said, also kind of unreliable. If it's not windy, then it's not going to generate any electricity. Right, the renewable energy resources to do with water, waves and tides. So waves, you know what waves are in the sea. You can harness the kinetic energy of the moving water. Tides is the moving in and out of water onto the shore. And hydroelectric is quite an interesting one. So with hydroelectric, what you've got basically is you've got to have a reservoir of water at the top of the hill. So I draw my little hill in a different colour. Here's my hill. Okay, and I've got a reservoir of water at the top of it in the hill. I've drawn that so badly, I'm going to draw it again. Let's draw the hill more like that so that it doesn't look completely ridiculous. There we go. So there's my reservoir of water in the hill. Now at the bottom, you have another reservoir of water. Okay, so you've got another store where you can store the water like that at the bottom of the hill. And your water stays at the top here. You've got a little dam that dams the water to stop it from running down the hill. Now, when you want the electricity, what you do is you stop the dam here and the water will flow down the hill to your other reservoir. Okay. Now, in doing so, what you have is you've got your little turbine kind of here in the hill. Probably a bit lower down, and your water flowing through the turbine will generate electricity because you've got a turning turbine again. Now that's really helpful because actually there's some times over the course of the day where people tend to need a lot of electricity. So one of the main times, interestingly, is the adverts in Coronation Street. Lots of people go and put their kettle on then to have a cup of tea, and there's a huge sudden surge in demand for electricity across the whole country. So they switch these on then, so you've got this little bit of extra electricity going into the national grid. Now, when it's not in use, what we do, and this is kind of the downside of it really, is this water that's moved from the top to the bottom has to be pumped back up to the top. Okay, and to do that you actually have to use electricity to pump it back up again. Okay, and that electricity could come from, let's say, a coal-powered fire station. So power station. So if you're doing that, then obviously you're kind of getting the fossil fuel aspect back in again. The other thing about water is sometimes you get dead plants and things in the water and they can release methane. Now methane, unfortunately, is another greenhouse gas. Okay, so none of these are going to be perfect, to be honest. This one's great. Geothermal electricity, geothermal hot water. You can use these, sometimes called hot rocks as well, I should say. It's just volcanic activity going on underneath the ground. It's used to heat up the water, to make the steam, to turn a turbine. Really, really great, actually. But you can only do it where it's volcanic, which is actually quite a hard place to find where you want to put your power station. But really nice method there as well. Again, same as the others. You don't have to put in fuel costs. You don't have to get any polluting gases. It's not going to run out. but a real problem about where you can put them. And solar is energy from the sun. Again, if it's a cloudy day, can be quite unreliable, extremely expensive to set up. And it takes a long time, if you put a solar panel on your house, to make enough money back again, if you see what I mean. It costs a lot of money to put them on your house. Then you would have to have it for quite a number of years before it kind of pays itself back. And again, if it's cloudy, it can be a bit unreliable as well. And you're going to watch a little video in a minute about how to make a solar panel, which is quite interesting, which I found on Key Stage 3 Bite Size. I'm going to leave that there because I've been talking a long time. And again, I apologise for when I had to stop because there's someone at the door, and equally when my very bad writing. Okay, have fun, guys. Have a nice day. See you later.